Okay, so here we go. We've got our first example. We have a paintball being shot out, so it's going 90 meters per second. It's aimed so the gun is completely horizontal. I've drawn a little sketch there showing that the paintball gun is 1.2 meters off the ground, and the first thing I want to know is how long it's in the air. Now, anytime you do a projectile motion question, your very first thing you need to do is determine what vertical information, whoop, learn to spell, what vertical information do you have, and what horizontal. So I want to know, what do I know vertical and what do I know horizontal. I need to make sure I separate these because remember, horizontal, we are only going at a constant velocity. So the only equation I can use is v equals d over t, right? That's all I got. However, vertically, I can use the kinematics, right? I've got those 5 equations, and that's because it's accelerating due to gravity. So that's important to realize. So I'm going to read my question again. It tells me it's 90 meters per second, and it's completely horizontal. Remember, we said that means the horizontal velocity must be the 90, and the vertical, or V1, is 0. And that's because all of it went into making it go horizontally. There was none vertically, so it starts off at 0. The 90 cannot be used for both. It can only be used for horizontal. Then I'm going to think of what else I know. Well, I know my 1.2 meters, and that's the height off the ground. So that's how far it will fall vertically before the ground stops it. I have no idea how far it goes horizontally. We're going to solve for that in part B. The last thing I know is it accelerates due to gravity. It's going to speed up because gravity is going to pull it. So it will accelerate at that rate of 9.8 meters per second squared. Excellent. I need to know the time. I obviously don't have enough information for this, right? Because I don't know this d, I can't figure out the time using it. But I can using the kinematics. So for part A, I'm going to use a kinematic equation in order to solve for the velocity. So I'm going to look at my equations, and I'm going to pick the one that has everything I have and the time, the thing I need. So I'm going to pick this guy. I know my distance was 1.2 meters per off the ground. Velocity is 0 to start, so 0 times t is still 0. Half of 9.8 and the time squared. I'm going to simplify this. Remember, if you can put this right in your calculator at this point, that's fine. I'm going to simplify it just to make it easier for those that are watching and find that it's 4.9 t squared, right? Because half of 9.8 is 4.9 and the 0 goes away. I can now divide my 4.9 into my 1.2 and square root it, and this will give me my time. So that's what I'll do. Now, when I go to do this, I will get I'm going to write down my unrounded and my rounded number. So I get 0.4949 unrounded. I'm going to round it to 0.49 for sig figs because sig fig wise, although there's 3 in 1.20 and in the 90, I used 9.8, so it still counts. So I'm going to round that for my final answer. However, I am keeping this one in order to be able to use it in my calculation for part B. So come to the next video and you will see me solve for part B.